Let's do chemical bonding in chemistry. Alright, let's discuss chemical bonding. By definition, chemical bonding is simply a lasting attraction between atom, ions, and molecule that enable the formation of chemical compound. That's like the definition for chemical bonding. Also note that atom of element tends to combine in order to become stable. This combination to form a compound affect their individual electronic configuration. How this electronic configuration changes when atoms are combined forms the basics of chemical bonding. So when it comes to chemical bonding, we have two atoms or ions or molecule combining together in order to become stable. That's the purpose. So the main purpose of chemical bonding is for two atoms to combine in order to become stable. Basically, that's your definition for chemical bonding. When it comes to chemical bonding, there are two different types of chemical bonding. The first one, they will have what we call the electrovalent bonding, also called the ionic bonding. Number two, they will have what we call the covalent bonding. When it comes to covalent bonding, there are two. We have the ordinary covalent bonding, and number two, they will have the coordinate bonding. Let's look at this type of bonding one after the other. Let's discuss types of chemical bonding. Types of chemical bonding. Let's discuss the types of chemical bonding. We said there are two types of chemical bonding. Number one, we have what we call the electrovalent bonding, also refers to ionic bonding, perhaps ionic bonding. Either I call it electrovalent bonding or per se ionic bonding. That's number one. Number two, we have what we call the covalent bonding. We have what we call the covalent bonding. Under this covalent bonding, there are two. We have the ordinary covalent, and number two, there we have what we call the coordinate covalent bonding. These are like the two types of chemical bonding that we have. Number one, we have the electrovalent or ionic bonding. Number two, we have the covalent bonding. There are two there. We have the ordinary covalent bonding, and number B, there we have the coordinate covalent bonding. Let's look at this concept one after the other. Let's discuss the concept behind electrovalent bonding. Let's discuss number one. Let's discuss electrovalent bonding. Let's discuss electrovalent bonding. All right, let's call this one. Basically, when it comes to electrovalent bonding, put down, please. Electrovalent bonding, also called ionic bonding, involves the transfer of electron from one atom to another. The transfer and acceptance create ionic or charges particles which are attracted to each other. So basically, when it comes to electrovalent bonding, the keyword there is transfer. So when it comes to this one, two element tends to be stable by transferring that what electron, right? So when it comes to covalent bonding, we are saying that the major focus in definition is what is transfer of electron. So when it comes to electrovalent bonding, we do with the transfer of electron from one atom to the other. So let's consider a particular question there, and let's see what we get. But let me ask you a question. If an atom is transferring electron, right? If an atom is transferring electron, what kind of ionic species is formed? If I say ionic species, will it form positive or negative? If an atom is transferring electron, is it positive um, species or negative species? Which one will it form? Observe that that atom is transferring, is donating. So, and we said last class before now that we said that atom gain electron to become negatively charged, and lose electron, transfer, donate. Sorry, we said atom gain electron to become negatively charged, right? And loses or transfer or donate electron to become what they positively charged. So my answer then become positive because we said what kind of ionic species is formed when an atom is donating or transferring electron. That becomes what the a positive what species is formed, right? Let's take a quick example to further explain electrovalent bonding. Example: consider the kind of bonding that occur in sodium chloride. Example: consider the kind of bonding that is formed or perhaps that occur in sodium chloride. Example: we are asked to consider the kind of bonding forming what? Sodium chloride. Basically, let's get this done, please. We are asked to consider the kind of bonding. Is it electrovalent bonding or covalent bonding? Let's see how we get this done. Basically, in these two cases here, there are two elements here. There are two atoms here. We have the sodium and what? Chlorine. Basically, let's analyze this one after the other. For sodium there, for sodium is Na, atomic number 11, right? Also, I'm having chlorine, Cl, atomic number there 17, right? So in this case here, if sodium, right, if sodium Na, if sodium, for sodium now, basically when it comes to electronic configuration, electrovalent bonding, we do what we call the KLM shell concept. So I want to ensure that these two atoms, when they combine, they are stable, right? Let's see, for sodium, let's draw out the shell, KLM shell concept for sodium. For sodium there, I should have a 281, right? For sodium, let's have sodium. For sodium Na, the shell becomes, start with K shell 1, 2. This one contain 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 with 2, that's 10. And we're going to 11, right? So I have one more shell here. That's 11, right? Or perhaps I can put it anywhere I want to. Let's say I put it here. I put it here. I have this. This is 11. This for sodium. Let's consider chlorine. For chlorine, atomic number what there? 17, right? Let's draw the shell for this man here. That should 287, right? 287 here. 287. This should be 2. This is 281. This should be about 287. That is, start with K shell 1, 2, L 1, 2, 3, 4, 5, 6, 7, 8. This is 10 in total. Left is 7. Next shell have this maximum 8. So 1, 2, 3, 4, 5, 6, right? And 7. So this is what? 17. This is 2, 8, that's 10, with 7, that's 17 electrons here. So now we're saying that when these two elements or perhaps atom combine, when these two combine, right, are they going to be transferring electron, right? So let's see if they're going to be transferring electron, because when it comes to electrovalent bonding, the keyword there is transfer. So let's say how this is done. So in this case here, if I have sodium combining with chlorine, what's sodium? I have this man here. So draw sodium. This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I have 11. This for sodium. Combining with chlorine. What's chlorine there? Combining with chlorine. What's chlorine? This man here. So I have chlorine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 11, 12, 13, 14, 15, 16, 17. Now, question. Before I start transferring electron, question. What's the main focus? Why are we transferring? Here's a key concept. Ask yourself, is sodium stable? Ask yourself, is chlorine stable? If they are not, then you can transfer, right, or donate. Now, in this case here, now look up please. In this case here, question, is sodium stable? Last class, from when we discussed about chemistry, from our previous videos, we said, and for an atom to be stable, there are two conditions there, right? There are two key terms there you need to note. For an atom to be stable, it must be either duplet or octet configuration. By duplet configuration, we mean it must have two valence electron at the atom's shell. By octet, we mean it must have just 8 valence electron. Observe that this is just what? 1 electron at the atom's shell is not balanced. If it was 2 electron, then it's balanced, but it's not balanced. We said the condition is that if it's 2 or 8, this one here is 7. This atom's shell, this last shell, has 7 electrons. It's not balanced, it's not stable. So if you want to make it stable, it must be 8. We said the concept of stability of an atom are in need of two things, either duplet or what, or octet. So this one is neither duplet or what, neither octet. So it's not balanced, they're not stable. So how can this one be stable here? The stability now depends on this. Look up please. Look up please. It's easier for me to transfer this 1 electron that's here in sodium to chlorine than transferring 7 electron, all the 7 electron down here. It will be more complex and stressful. So the easiest one is what? I'll transfer this electron to chlorine here. Let me call it times. The transfer electron, let me call it times. So observe that this sodium now has transferred the 1 electron at the atom's shell to what? To chlorine. So that chlorine can become what there? An octet can become stable, right? So now in this case now I'll be left with just for my sodium now I'll be left with just what? This one here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For sodium, I'll be left with, although this one now, I'll transfer this one. So nothing left is here. Also, I'll be having, for my chlorine, I should have this left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Of course, 11, 12, 13, 14, 15, 16, 17, 18. This one here is the transferred electron, right? So this X signifies the transferred electron. So observe that we said the stability of an atom depends on two things, either duplet or what, or octet. Look up now. Sodium now is what? An octet condition. 8 valence electron is balanced, is stable. Chlorine now also observe is 8 valence electron at the outermost shell, hence is what is stable. So this becomes how to this is called the idea basically behind electrovalent bonding, the transfer of electron from one atom or ions or molecule to another. So the purpose is that for them to be what to become stable. So sodium is stable now, and chlorine is also stable. But mind you, so the sodium gave chlorine just one electron to become stable. So I have this here. So the key concept to note is that when it comes to electrovalent bonding, we did it with transferring an electron until both atoms become stable. So observe that sodium is stable, chlorine is not stable. That's our purpose. All right. Put on place. Other example of electrovalent bonding include other example of electrovalent bonding include number one, MgCl, right, magnesium chloride. Number two, KCl, potassium chloride. Number three, MgO, magnesium dioxide. Number four, we have Al2O3. So I have this. So these are other examples of electrovalent bonding. Basically, I've given you NaCl, that's sodium chloride. I'm giving you MgCl2, KCl, MgO, A2O3. These are other example of electrovalent bonding. Let's just do two. Let me do this first one for you and this one, and then we'll off. Let's prove that this one and this one, these two are simple. Let's prove these two being a condition under electrovalent bonding. All right, for these two there, what do I get? Basically for these two, let's what we get. Let's consider magnesium chloride, please. Look up, please. Look up. For this one here, I'm having magnesium combining with what? Two chlorine. So let's say magnesium is here combining with chlorine, combining with what? Chlorine. 1 plus 1 is 2 chlorine with magnesium combining. Let's see what we get. Magnesium is atomic number 12. So draw your shell. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But let me just put it here. 11, 12. This is my magnesium. 12 electron. Chlorine is of course 17 electron. Let's draw out chlorine. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This chlorine. On that chlorine here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 11, 12, 13, 14, 15, 16, and what? 17. This becomes your shell for these two atoms here, magnesium and 2 chlorine, right? So let's see if it's balanced. So how does this balance? Question, please. Ask yourself, please, is chlorine balanced? No. This is 7 electron at the outermost shell is not balanced. We said either is 8 or 2. This is not balanced. Ask yourself, please, is magnesium balanced? Of course, yes. This is 2 electron at the outermost shell. So magnesium is balanced in this case here. Is chlorine here balanced? No. No, it's not balanced. And I say that basically, when it comes to atomic configuration, we ensure that we transfer electrons such that all the atoms in all the atoms become stable. This one is not stable. This is not stable, but this one is stable. Now, here's the concept. This one just need one electron for it to be stable. This one also what need one more electron to be stable. Basically, I can transfer this one electron to chlorine. Also, this one electron to what? To chlorine here. So, in other words, I'll be having something of this nature left. I'll be having chlorine in this form left. Sorry, 1, 2, 3, 4, or perhaps if I want to save our time, observe that these two electron here are be transferred to chlorine to the right and to the left. So I'll be having something of this nature left. Observe. Observe. So something of this nature. So the last shell will be removed. In other words, chlorine now has become stable with this one electron attached to it. Chlorine here has also become stable with this one electron attached to it. Also, magnesium, irrespective of these two electrons that has been donated or transferred, it still has what? An octet configuration. So it's a stable atom. So it becomes your concept that MgCl₂ is actually going through an electrovalent bonding, the transfer of electron. Let's do number 2. Let's look at aluminum. Let's do number 4. Aluminum 2, oxygen 3. Let's see how we get that one done. For my aluminium, I have 2 aluminium there. Let's combine the 2 aluminium with the 3 oxygen, right? And let's see what we get. Oxygen is atomic number 8. Aluminium atomic number what there? Number 12 per se. Number 13, please. 13. So I'm having, let's consider aluminium 2 and O3. We said aluminium is 2 here. So aluminium, we said aluminium is of course 13 electrons. Oxygen is 8. Let's say I get this done. I'm having 2 aluminium. Let me put one here. Start with this one. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This aluminium, 1 aluminium. Let me put the second one here. Under aluminium here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is 2 aluminium. Oxygen is 3. So let me put one oxygen here. This oxygen is 8. So 1, 2, 3, 4, 5, 6, 7. Sorry. Okay. 7, 8. This is 2, 3, 4, 5, 6, 7, 8. This is 8 here for oxygen. This is 1 oxygen here. Let me put another oxygen here. 1, 2, 3, 4, 5, 6, 7. Sorry. Sorry. 1, 2, 3, 4, 5, 6, 7, 8. That's on the oxygen. Let me put one more here. One more oxygen here. 1, 2, 3, 4, 5, 6, 7, 8. These are what? 1, 2, 3. 3 oxygen. 1, 2, 2 aluminium. The question, is this balanced? Of course, oxygen here is not balanced. It's 7, 1, 2, 3, 4, 5, 6. Perhaps it's 6 electron atomos shell. It's not balanced, right? Oxygen here is not balanced. Here is not balanced. Also, aluminum 2 is not balanced. I'm having 3 electron at atomos shell. It's not balanced. So let's balance this up, please. How do you get this done? Perhaps if I want to, I can add a plus here. Combine, and combining, right? They are combining together. All right, here is the concept, please. For this oxygen to be stable, I need 2 more. So I'll transfer this one and this one, right, to oxygen. I'm having one left here. Transfer this one to this place. This one here, transfer it to this place. Having two here, take this one to this and take this one to this. What do you observe? Observe that this is now stable. This is now 8 outside the outermost shell, stable. This one here, it has donated all the outermost shell. So I should be left with just this. If I clean up these ones here, the shell will be erased because I transferred the electron there. So I'll be having 8 outermost shell here, right? So I have this. By the way, there was 3 outside before, but it has what? Transferred or perhaps donated it to the oxygen here. It donated 2 here, 1 here. So there's nothing outside here. It's become 8 outside there. It's balanced, it's stable. Also observe that this one here goes to this. This 2 here moves to this. So hence I'll not have this shell again because it has transferred its electron to the oxygen here and here. It transferred 1 here, transferred 2 here. So observe that this is now balanced. This is now 8 outside the shell. This is also 8 outside the shell. This is 8 outside. This is 8. This is 8. So this becomes a balanced or perhaps a stable, please, a stable atom. So this is how electrovalent bonding works. So the transfer of what the electron, right? So the donation of electron. So you can just try doing this too as an assignment and send it to my WhatsApp number, as you can see, so I can reply you if you are wrong or correct. Let's do the second type of chemical bonding called the covalent bonding. So before I move on to the next one, note that in JAM, if I see any compound or perhaps any compound of this nature, I should know that this is a what an electrovalent bonding. So just cram it. Your idea is to cram. Even I don't believe in cramming, by the way. So if I give they are given if they ask you that is MgCl₂ is MgCl₂ a condition under electrovalent bonding or covalent bonding, how do you know? Draw out the stuff outside first, as I did here. Then you now observe. So it becomes a transfer, becomes what they an electrovalent bonding. So whenever you are given in JAM question, just try to draw out the shell and then you transfer them. So just basically, I give you 4. Sodium chloride with this ones here becomes 5. So memorize them. Whenever I see them in JAM, they are all what? They are under what the electrovalent bonding, the transfer of electron. Lesson number 2 in the next class. Lesson number 2, covalent bonding in the next class.